Hello everyone, this is Richa Garg. I welcome you all at School Quiz. So today we are going to start with chapter 1 exercise 1.1. We have discussed all the concepts in the last videos. Please go through it. Okay, and now we are solving the questions. NCRT book. Yes. So let's start with the first question. Is 0 a rational number? Can you write it in the form of P upon Q? This is P upon Q, sorry. And where P and Q are integers and Q not equals to 0. So as we have learned, rational number can be a number which can be written in the form of P upon Q with one condition, specific condition, that is Q cannot be equals to 0. But we do not have any condition like P cannot be equals to 0. So P can be equals to 0. When, please understand this, when P is equals to 0, Q will automatically be 1. Like for example, if I'm taking 5 as an example, okay. So if 5 is a rational number, what I will say P is 5 and my Q is 1. Great. So we can say yes, 0 is a rational number. 0 can be a rational number. When written in the form of P upon Q, it will be 0 upon 1, where P and Q both are integers and Q not equals to 0. Got it? So let's move on to the next question. Find 6 rational numbers between 3 and 4. The formula we have learned was A plus B upon 2. So A is 3 and B is 4. So A plus B upon 2 is 3 plus 4 upon 2. That will be 7 upon 2. So my first number is 3, 7 upon 2, 4. Now take this group, or you can take this group, anything you want. So now A is 3 and B is 7 upon 2. So 3 plus 7 upon 2 divided by 2. Now 2 is the LCM here. 1 2s are 2 and 2 3s are 6. 6 plus 7 multiplied by 1 by 2, reciprocal of 2. It will be 13 upon 2 multiplied 1 by 2, which will be 13 upon 4. So my second rational number is 3, 13 upon 4, 7 upon 2, 4. Now you can take another group as you want, but I am taking the center one because the LCM is easy. No other explanation. So now A is 13 by 4 and B is 7 by 2. So A plus B upon 2 again. Formula will be same. So 13 upon 4 plus 7 upon 2 divided by 2. It will be 4 LCM 13 plus 14 divided by 2. 13 plus 14 is 27 by 4 multiply 1 by 2, reciprocal of 2 again. So 27 by 8. Right? So my new numbers are 3, 13 by 4, 27 by 8, 7 by 2 and 4. Now you can take any two pair. I am taking the last one, 7 by 2 and 4, because I think the calculation will be easy. Okay, so A and B. I have got 3 numbers for now. So let's start. A plus B upon 2 again. We should write formulas every time we solve a question because it gives us an extra edge. So 7 upon 2 plus 4 divided by 2, which will be 7 plus 8 upon 2 multiply 1 by 2, reciprocal of 2. 7 plus 8 is 15 by 2 multiply 1 by 2, which is 15 by 4. Now let's write the numbers here. 13 by 4 was there. 13 by 4, 27 by 8, 7 by 2, 15 by 4 and 4 at the end. So we have to find 6. We have find 1, 2, 3, 4 numbers are there. So fifth rational number. We can write it like this also. Fifth rational number between 3 and 4 is, let's find it out. Okay, now which pair are we going to take? Let's take 7 by 2 and 15 by 4. So A is 7 by 2 and B is 15 by 4. Again, A plus B upon 2 will be 7 by 2 plus 15 by 4 divided by 2. So now 4 LCM 14 plus 15 multiply 1 by 2. 29 by 4 multiply 1 by 2. 29 by 8. So the numbers, 5 numbers now I have is 3, comma 13 by 4. 13 by 4, 27 by 8. 7 by 8. Then we had 7 by 2. It's good to check once. So 7 by 2, 29 by 8, 15 by 4 and 4. Getting it? Now let's check. Okay, we have to choose one pair. Let's check 27 by 8 and 7 by 2. Again, easy calculation. No other reason. So 27 by 8 and B is 7 by 2. A plus B upon 2. So 27 by 8 plus 7 by 2 divided by 2. LCM 8. 27 plus 2 4s are 8. So 4 7s are 28 divided by 2. What you can do now? Add them. 8 7 15, 2 2 and 4 is 5. Sorry. This will be 555 upon 8 multiply 1 by 2. So 55 by 16. Now, okay. So we have got the 6 rational numbers. So answer will be 3, comma 13 by 4, 27 by 8, then 55 by 16, 7 by 2, 1 2 3 4, 5 and 6 is 29 by 8, 15 by 4 and 4. Here I am. Okay, so 1 2 3 4 5 6 numbers are there. Now, a long process. Okay, we have taken 6 sheets to complete this question. A big calculation, right? So we have one more method. We have already talked about it, but let's do it again. So my numbers are 3 and 4. Yes, I have to find 6 rational numbers between these numbers. So what we can do? We can follow a very simple method, which is if I'm writing it in rational form, it is 3 upon 1. If I'm writing this number in the rational form, it is 4 upon 1, right? I have to find 6 rational numbers. So just add 1 in this, it will be 7. Now multiply this 3 by 1, multiply 7, and here 4 1 to 1 multiply 7 again. So 28 upon 7, and this will be 21 upon 7. Now this is very easy. When the bases are same, I can find 21 6 rational numbers between 21 and 28. It will be 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. So 1 2 3 4 5 6. Correct? 6 rational numbers we have got. So I can make it 3 and 3. Got it? So this one is easy. We have just taken one sheet to solve this question. So I will prefer this method only as it is given the NCERT also, if your teachers allow this method. Okay. Next. So third question now. Find 5 rational numbers between 3 by 5 and 4 by 5. Now again, please see the method can be same. A plus B upon 2. Yes, but I will prefer that we can solve this question with the second method. I have to find 5 rational numbers, right? So 5 plus 1 is 6. Multiply both the numbers by 6. Now the question arises, one question you should have in your mind. that if bases are not same, we will have different bases again, right? And when the bases are different, we have to find the LCM and it will take a lot of time. So what we have to do is we have to find the bases first. We will equalize the bases first, then we will multiply it with the numbers we have to find out. Okay, so 6 3s are 18 upon 30, it will be 24 by 30. Find out the numbers. So it will be 18 by 30 comma first number, 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30, and then will come 24 by 30, or we can write it as 3 upon 5, and this is 4 upon 5. So 1 2 3 4 and 5. It's that easy, isn't it? But if you want me to solve this question like this only, please tell us in the comments, okay? And I will solve the whole question. Now, the next question we have is true and false. So first statement we have, and we have to give reasons also, okay? So please concentrate on the reasons part. Now, every natural number is a whole number, is the first statement. Okay, if you remember in the number system video, we have done this start. Please go through this start. It is very important for you to know the numbers. So the question we have is every natural number is a whole number. So let me explain this with this. So every natural number is a whole number. Is it correct? Natural numbers are a part of whole numbers. Yes, 0 to infinity are whole numbers and natural numbers are 1 to infinity. So this falls in the whole numbers. It is a category of whole numbers. So this statement is true. Reason being that natural numbers goes from, so sorry, 1 to infinity, whereas whole numbers goes from 0 to infinity. So this 1 to infinity falls in between 0 to infinity. Thus, now every natural number is a whole number. Got it? Now, next, every integer is a whole number. Now, let's move again. Now, as you can see, every integer is here is a whole number, and whole number falls downside of integer. It is a category of integers. Now, can we say every integer is a whole number? No, the statement is false. Why? I will tell you. Integers are from minus infinity to infinity, whereas whole numbers are from 0 to infinity. As you can see, negative integers are a different category. So every integer, if I'm talking about minus 4, if I'm talking about integer minus 4, is it a whole number? No, because it falls between the category of negative integers, not under the category of whole number. So the statement here is false, right? Reason being, integers are the numbers from minus infinity to infinity, whereas whole numbers are the numbers from 0 to infinity, that is only positive numbers. It never includes negative numbers. So the statement is false. Every integer cannot be a whole number. But if I have a statement like every whole number is an integer, can I say this? Every whole number is an integer? True. Because every positive number falls in the category of integer. Right? Okay. So the next statement we have is every rational number is a whole number. Let's see this now. Every rational number. Just see it yourself first. Every rational number, where are rational numbers? Is a whole number. Now, whole numbers is a subcategory of rational numbers, right? So, can every rational number be a whole number? No. Why so? Because a rational number includes fractions, whole number doesn't. You can see fractions are different category and whole numbers are a different categories. Then, rational numbers also include negative numbers, but whole numbers doesn't include negative integers. So I can say the statement is false. Understood? Rational numbers, okay, let me write it. Rational numbers, reasons are a lot. So first reason is rational numbers goes from minus infinity to infinity, whereas whole numbers goes from 0 to infinity. Only positive numbers, it includes negative numbers also. The second reason being rational numbers have fractions also. Okay, whole numbers does not include any fraction. Okay, it is a whole number. Only numbers which are in the form of 4 upon 1, 5 upon 1, 20 upon 1, like this one. Okay, so the two reasons are it doesn't include fractions or any negative number. So every rational number cannot be a whole number. So this is all for today. Thank you so much for watching this video, and if you have any doubts, just leave us a comment and we will try to solve each and every query. Thank you, and let's meet with another content.